So for this one, we're going to transfer our structure that we got from the worksheet 10. We look at, actually maybe I'll just, what am I going to do? I'll draw it over here. So this is the Lewis structure that we came up with. So that's what you're looking at on worksheet 10. And then you're going to use that to answer these questions. So there's identifying the molecule, electron groups. So it wants us to look at our Lewis structure and identify how many electron groups around the central atom. Well, there's 1, 2, 3, 4, 5, 6 bonds, right? So we have 6 electron groups. And then it's asking, well, how many lone pairs on the central atom? Well, I look at this central atom, selenium, and there are no lone pairs. So that's 0. From that, I can determine the electron geometry. I've got 6 groups. 6 groups make an octahedron. And I don't have to consider those yet. The electron geometry is octahedral.
How did it become octa? With 6 groups, there's 6. Wouldn't that be like a hexa?
No, because an octahedron has 6 points. It has 8 sides. It's confusing. Yeah. Those 3-dimensional geometric figures are named for the number of sides that they have. And so here we're looking at 6 things getting away from each other, but they make the shape of an octahedron.
Kind of like dice, almost for like Dungeons and Dragons.
Yes, like those multi-sided dice. So if you take an octahedral die, which has numbers 1 through 8 on it, and you count the points instead of, you'll get 6.
Okay.
So for molecular geometry, so we have the octahedral geometry for the electrons. If the lone pairs are 0, it's the same. If the lone pairs are not 0, then we have to imagine invisible lone pairs and describe what's left. But this is also going to be octahedral. And now this is where you can, if you're artistic, you can let loose. We're supposed to draw a perspective drawing and include the bond angles. So I am not looking for works of art here, but I want to see that you tried to make it look 3-dimensional. So we've got a central atom, and there's an atom above and below, and then there's 6 of them around the middle. Another way that we'll do this is we use wedges to show that it's jumping out at you, and hashed wedges that it's going behind, and straight lines to indicate that it's in the plane. So you can do it that way too if you want to. And then include bond angles. Now, if you've got lone pairs, I just want you to adjust them by saying greater than or less than. But here, all of these bond angles are going to be 90 degrees. And so you don't have to try to describe all of them, but just indicate that way. And filling this out, you can use the PhET simulation to help you, right? Any questions?
Can you do one that has like PO43
Sure.
minus?
Sure. Is that one of the ones on here?
Yes.
Why can't I find it?
It's below, yeah, it's below PI5. I think you just passed it. Oh, it's different in yours.
Is it different?
Yeah, slightly. Well, it's PO43 minus.
Let me check that. Because that shouldn't be. Are you looking at worksheet 10 or worksheet 11?
No, I'm looking at worksheet 10.
Okay,
Because
not all of the molecules or ions from worksheet 10 are on worksheet 11.
oh, okay. No, I'm just looking at worksheet 10. I thought.
Yeah,
all
but
of
we
them
can we can look at worksheet 10. Definitely. Yeah,
right there.
right there. Yeah, we can do that one.